Hello to viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Astrobase Space Everest engine. So let's dive deep into it. So this puppy, Astrobase Space, is a Bangalore-based tech startup. Basically, Bangalore is our Silicon Valley, and it was founded in 2024. So it's a very young puppy, like horrifyingly young puppy. And Niraj and Dev Kumar, these two individuals are the main horsepower behind it. And the key ingredient, basically starter ingredient, I should not say key ingredient, starting ingredient is that Indian government wants a private partnership. So they are like, okay, they created a big grant, which is in space technology adoption fund. So if you show your company and basically if ISRO finds it worthy, they're gonna give you some amount of money from that fund. It's not that big, that's why I'm pretty sure they have a venture capitalist fund, but so far, again, as I'm making this video, as I have checked it, it's may not be open to public, as in like where did they got the money, because again, I know Skyroot got a lot of international funding, so there is a very good chance they also got it, because again, the in-space technology adoption fund, it's better than zero, but it's really not that much. So that data is missing. Again, it's not illegal, or again, government changed the law, so it is not illegal at this point in time. It's just that they are not sharing that with the public. And their core essence, like what they are bringing to the table, is this rocket, which is not the key point. They know that rocket is easy. They know the hard part is engine. Basically, if you think rocket is hard, hardest part in the rocket is the engine. So they're like, okay, we're gonna focus on engine first before we, because again, you can do tanks at the side, but you can't do engine side project. Engine has to be the primary project. So the core essence is rapid, iterative engineered, powered by large 3D printer. And when I say large 3D printer, I mean it. The printer is huge. How huge? You have to take stairs to climb to the top of it. It's huge. It's huge. And by the way, multi-laser, not just one laser, multi-laser, 6 laser if I'm not mistaken. It's a huge puppy. So, and in-house. By the way, because these printers are so idiotically expensive, there are a lot of companies that buy this printer and they just rent out its services. You can do that. Many companies are doing that. However, that does limit your iteration cycle. Here, they are like, no, rapid, in-house, go. So what is their USP? Because again, market right now, Indian market has been flooded with a lot of space startup. We want this because again, if 100 to 200 companies try, then I have some chance that by 2030, it should be normal for me to just talk about like multiple space providers in India. Again, I do not think like if 200 enters, 200 will go out. But I think 200 enters, 5 should go out. You know, whereas like, no, we got orbit, like we got you fam. So their key vector is they have two main puppies. One of them knows business, as in like they made actual money in blockchain technology. So again, 10 years, like they have some serious chunky money. And then you have another one who again is an ISRO scientist, has worked for more than 10 years, almost 13 years of work experience with cryogenics. So you are talking about two puppies who are master of their domain. One knows engineering well enough to like, no, I got this. Another knows business well enough to like, I got this. So that's their main, what you call, steering wheel. Second, they have competent talent. The things they are doing is like, it shows like they have either a lot of ex-ISRO agents or like someone competent. Like things they are doing in 2 years is like, yeah, this cannot be done with just like hee hee ha ha. It's like somebody knows. Or maybe this was cooked behind the scene for years. That is the only reason why you can do that. And their capital efficiency is very good because the money is tight. No matter who venture capitalist is, you always want to be efficient with your capital. If things are expensive, duh. But you have to be efficient with that. Because again, they're not buying cheap things. That printer is expensive. So the fact that they went from company registration to actually ready to fire engine. Again, they did do fire, but on a small scale, like, you know, injector testing and all that. But like reaching to a point where you can see, okay, this is the rocket engine we are building. And I only started 2 years ago. That's fast. And so far, so good. Almost reaching the same point where the other companies can. They built this dedicated cryogenic testing center. This is a big deal because while there are a lot of companies in India, ISRO knows this data point from a fact that not everybody has a rocket test site. Yes, you can build a small testing site in a remote area where you can test some thrusters or a very small engine, but anything significant orbital class rocket engine, even one of that engine, yeah, that's not happening. None of them have that. So right now the current approach is that you go to ISRO, ISRO organizes it for you. Problem is ISRO organizes it with you. For example, if ISRO has priority requirement for any of the national project, let's say, Navika navigation systems or PSLV upgrades or GSLV Mark III upgrades or whatever have you, yeah, you gonna be like, no, you're just gonna be slide. Like you have to deal with that because again, ISRO's infrastructure is for ISRO first. Then you have a lot of other companies also betting on that same infrastructure. So lot of scheduling hassle. Now, the idea is, of course, they're gonna go to ISRO for the final testing, but to do rapid iteration, counting on ISRO is like government bureaucracy, you did. So the idea is they're gonna build their own test stand, cryogenically full scale test stand, and they're gonna do rapid iteration here. Once they're fully ready, fully cooked, they are satisfied, then they're gonna go to ISRO. That is far more what you call a logical approach. So that's why I'm saying, like, they have money, serious money, they are spending it very seriously, but the way they are spending it is what you call very mature, where it's like, even if the company goes bankrupt, this will be very profitable sell asset, and more companies are coming up, so they will need more and more test site. They're like, bro, we have it. Heck, they might do the other approaches like, hey, if you have an engine within this class range, let's say 200-ton thrust class range, you can come here and test it. And I can easily see that, assuming they have that sort of wiggle room left, they can recoup investment from this very effectively. So this shows a certain level of what you call maturity. Even the 3D printer, assume the company goes bust, that printer still would be valid. It still would be like, hey, we have this 3D printer, we can actually spin it up, either sell it out for a bankruptcy or spin it up as a service. Tangible benefit, so to say. So they have a certain level of what you call maturity. Like they built a stand, they tested the what you call turbo pumps, which was very clever because again, how the heck you gonna spin a turbo pump? You need a multi-megawatt class motor that spins at like 30,000 RPM or maybe more than that. Yeah, that's not happening. So they're like, hey, what if? Hear me out. We flow water through it. Again, water pumps are available. Multi-megawatt class water pump is like, bro, who cares? So what if you use that? Again, it's stressful because water is high density compared to methane or even oxygen, but clever. So they do have certain things that tell me that they have been cooking this for long ago. Like, they thoroughly thought out what we're gonna do, how we're gonna do it, what we're gonna build, and they have some grunt behind it. Now, full flow stage combustion, this puppy, assuming if you have not watched my video for years ago where I have already covered this, if you have watched that, skip this. If you have not, let's dive deep into it. So you start with LOX puppy and methane puppy. So you start with methane, CH4, liquid CH4, it goes in. Now you send it to the pump. Now pump dumps pressure into it, bonkers amount of pressure. You are talking about give or take 600 bars of pressure. Now that is GG amount of pressure. You have cryogenic liquid with bonkers flow rate that goes through the engine, so to say, basically the bell nozzle itself. So you cool this puppy. Now you have rocket fire going on here. So this bell cools down, the fluid that was cryogenically cooled at this point in time starts to boil. So then it goes into pre-burner. Pre-burner, you do math here. Basically, if you figure out, hey, I'm gonna flow give or take 133 kilogram per second, how much is the minimum amount or maximum amount of oxygen I need to properly vaporize this? So the small blue pipe that you're seeing, that is designed in such a way that it's like, let's just go with the number. Let's say they need 5 kilogram of liquid oxygen flow to make sure that when they burn 5 kilogram oxygen inside the methane flow stream, it will vaporize 100% of methane here. The key is, here when this cooling happens, some amount of methane becomes gas, not 100% of them. Here, 100% of them becomes gas, like, and again, high pressure gas. So that's what they're doing. And this GG fat pipe takes, basically, you have some amount of carbon dioxide, some amount of water vapor, and bonkers amount of methane gas going into your injector plate. Now, so far, this seems extra convoluted. Why you are boiling off all of your methane? If you look into F1 engine of Saturn V, that puppy had something known as combustion instability. Combustion instability is the side effect of liquid gas combustion or liquid combustion, meaning if you have liquid oxygen firing on a jet of liquid kerosene, you have to atomize them. On paper it sounds easy, oh, spew the jet, atomize it, burn it. Yeah, in real life is like lol. So it's never stable or clean enough, so it always has that hassle. So that's why they had like baffles and all that. But if you have pure gas mixing with another pure gas, no atomization required, it will burn cleanly without any combustion instability. That's why you have this fat pipe. That's why you are boiling off 100% of basically methane flow. And that's how you got your methane in your combustion chamber. Okay, now you take liquid oxygen. Liquid oxygen, you are flowing again generally at much higher rates. You are talking about 493 kilogram per second, and then you do the same mathematics you did it here. It's like how much methane I have to inject into this oxygen envelope to boil 100% of it. So let's say it comes out to like 3 kilogram per second or whatever have you. You have a very small tap off that goes into there, burns it, and then 100% of oxygen that is now gaseous goes into injector plate. Now you have two gas streams, high pressure, high flow rate, it burns. And because again the starting pressure was like 600 bars, even in this liquid turbo pump it was 600 bar. After going through all that hassle, you're still at 300 bars of gas here, and then you burn it. So then you go whoosh. That's how they achieve it. Now, they do not want to use a liquid oxygen or gaseous oxygen specifically anywhere. Why? That sort of gas at that sort of high pressure, high temperature, high flow rate, it will not cause damage, it will eat through it. Meaning there is no metal known to man that can handle that. So how the heck this area handles it? Well, this is the reason why oxygen one is on top. They are like, oxygen, oxygen, go. They do not want to like circulate and no, oxygen, go. That's the whole requirement. And this turbine is the black magic technology. As in, Soviet Union burned money like there is no tomorrow. America almost thought this was impossible to do. And SpaceX now have a patented metal that grows a ceramic layer in order to make so-called turbine that basically that oxygen reacts with it. It creates the ceramic layer that allows the turbine to survive. That's the black magic part. This is like difficult, but not impossible. This is black magic. Like how the heck you have a turbine that can burn 100, basically your burning part, that's easy. Burning, what is the flow? Flow is high temperature, high pressure, high flow rate, oxygen gas. Metal, it burns at that point in time. So somehow they have to have this black magic technology here. And that's the special sauce. Again, the plumbing is also a hassle. And you remember, like I talked about, like it is already pressurized. How? That's why starting a rocket engine is so cumbersome, and you can't just have a starter motor spinning these things up. You can't have enough pressure. So generally they use nitrogen flushing to start all of this, spin, start and all that. It's a very tricky ignition sequence, so to say. So you take oxygen, burn it, whoosh. You take methane, basically pressurize it, cool everything, boil it, whoosh. So that's how it works. And some amount is always tapped up. Like let's say you have some amount of liquid oxygen, you're gonna boil it and then send it back into your tanks to pressurize it. Again, I'm not sure whether Astrospace is gonna do that, Astrobase is gonna do that, but SpaceX does do that. And there might be some other circuitry also. I have seen people claiming that has helium circuitry, although I don't see why. You will hear this term helium seals. The reason is if you go into RS-25 engine, which is space shuttle engine, it had one what you call system that was spinning up both fluids. Problem is you have both fluids. If you mix them, kaboom. So how the heck you make sure high flow rate hydrogen does not leak through and mixes with oxygen and goes kaboom. Again, be mindful, hydrogen leaks through everything. So they have a seal gap. In that gap, they have high pressure helium. So basically, helium is forcing hydrogen to not leak. Oxygen is like easier to maintain. So in this, they don't have to do that, because here's the deal. What is the worst case scenario? This valve opens up fully. It's like whoosh. Nothing means, because this valve was designed from day one to choke flow, not extend it. Basically, this is not throttling anything. It's just like full throttle or zero. If this valve breaks, 100% of methane goes into the oxygen pre-burner is still within stress margin. It will not cause any issue. Same happens with this oxygen flow. What if this valve fails and it goes full flooding oxygen? Again, nothing will happen. Again, you will lose control authority, but it will not go kaboom. So that's why you do not need magical helium seal technology for this also. So only magic technology, how the heck you start this, and the black magic technology known as ceramic growing turbine blades. One thing that is benefit of going through this much trouble is the flow rate is high. Like you are talking about 133 kilograms of gas flowing through it. It's huge. Ask any compressor people like how huge that number is. It's huge. Meaning the turbine here is relaxed. It's like, it's not super duper high pressure. Sorry, pardon me. It's not super duper temperature, meaning it's not stressed. The metal is not stressed. It's dealing with almost something that feels like a gentle water flow. Like it is high density, so it does feel like water flow, but it's like much cooler. If you did not have this sort of flow rate, you had to keep temperature higher. Higher temperature, higher degradation on that. And again, same goes here, this oxygen system. You have to keep the turbines chill, brother. So you're overflowing it. You're like, again, you have to deal with the chemical part, but you do not have to deal with super duper high temperature also. And to achieve 300 bars in the chamber, the turbo pump output must be much higher than that. So in this design, again, I do not know the tangible mathematics of that, but generally they are at 600 megawatt range. So we are talking about something serious here. No seal required, turbines runs much cooler, and pumps can easily cross 500 bars. It is reusable. If you build this properly, you figured out how to start this puppy can handle multiple, basically this can almost behave like a jet engine where you just like turn on, keep it on. This is the good part of this, going through this much trouble. It is far more sustainable, and because of the fuel chosen as a non-kerosene fuel, it does not have that coking issue which Merlin has. And because it's not throwing any gas away, combusting all of them, and combustion is happening 100% efficiently, you are getting the most efficient topology known so far. So that's why people find this topology to be the holy grail. Like if you can build this, and if you can sort out all the wiring, issues, this is amazing. Now, what about this company? Well, here's the deal. One of the biggest asset is there, that multi-laser 3D printer, and they built a factory already, a starter factory, because they needed that printer. That printer required like freaking 3 trucks to deliver it. So they built a basically what you call a starting area for just getting things rolling, basically just building the engine. They needed area. That area can only handle 1 rocket. So they are starting it out. Now, why in Bangalore? Well, again, it's California of India. So it does have talent pool. Like basically, I used to live in Kormangla. It's an area. My house was there. So there is a restaurant where we used to go eat for lunch, Udupi. Next to that was ISRO. Basically, if you stayed there in Udupi, you will see a lot of ISRO scientists. You move in this section, you will find a lot of HAL scientists. Move a little bit more, you will find a lot of DRDO scientists. As in that whole road, old airport road, was filled with talent. More talent you can suck a stick at. So that's spot wise. From an aerospace point of view, it is talent rich in that exact thing. So they're like, we got the talent. Okay. They built this own testing stand, which is 21-acre area. It's huge. It's huge. And again, they're building the boom site in the center, because again, that's the whole essence. It could go boom. It should go boom once in a while, and it should not cause any harm to any public infrastructure or anything else. So it is middle of nowhere. In India, PESO approves this sort of thing. So they did got this. It is far, again, you can't do that in Bangalore. It is 250 kilometers away. How bad is that? Well, it's connected by highway, so I can easily, comfortably see that they can pack up the engine in the morning. Everybody can go home, have a good night's sleep, come early in the morning and just drive, and by evening they will have engine firing in that site. So it's far, but not that far. Heck, location wise, like this is Bangalore. Take a thread, go up, this is your airport. Go a little bit here, that's where my factory I'm building is there. They go a little bit more in this direction. Now you have this factory. And from there, then you go 250 kilometers up. That's where this testing site is. And their target is they're going to build a second factory, which will be much bigger. The idea is they're going to make 4 or 5 rockets per year. The reason is very clear. Salaries are fixed amount, time domain item. As in, you only going to pay 12 salaries per month, basically, in a year. So, okay, that's fixed amount. If you do 1 testing, you still pay 12 months salary. You do 50 testing, you still pay 12 months salary. So it's always better to have as much hardware richness as possible. This is why I'm saying, like, somebody either they already knew they're gonna do this. This is like they register the company the last thing, as in like they built everything, sorted out everything, who is gonna do what, everything was sorted, and then there's like, okay, let's just register the company. So that does show a certain level of maturity. It's like, we know we're gonna make a reusable rocket, but factually the likelihood of we're gonna make a rocket it's gonna work is 0. Again, it could happen, but again, they are directly trying Everest engine. They call it Everest because it's the most complex engine there. So the likelihood is very low, and they cannot be like, oh, we fell apart because our first engine went boom. They have to be rich enough hardware wise that they're like, yeah, no, we can try 5-6. That's why that printer in-house matters. That's why having on launch site testing, let's say they tested this, goes boom, ISRO will become very upset with you. If it's your own launch site, who cares? So, and their aim, what they're targeting for is 1 hot fire per week, so they can reach the final spot that they are thinking, basically orbit in 2028. That is way too optimistic, but again, they may have been working behind the scene, because this is the turbo pump assembly testing. They flow high pressure water through it to test it. I do not know, like from a pressure point of view, I don't get it, because again, water is much higher density. So is it a valid test or not? But apparently it is for them, so they are using it. And yeah, do not worry about that sort of what you call plumbing mess. It will go away once you actually have finalized the engine design. So what can we expect in the future? Well, they have just completed the first build. Again, this has not been fired. Trust me, as someone working with engines, if you make an engine and you fire it, it works, you're not gonna shut up about it. They have not shared it. So it's not been fired. They have built it, showed it, and they did had a small mock-up, basically injector test and all that mathematical testing. They did have fire, where it's like, okay, liquid oxygen and all that. They did that. So they know what they're talking about, but this puppy has not been fired yet. This has been demonstrated that we have built this, and we're gonna carry it to our cryogenic test site to test it. But again, that's the hard part. So they are taking very right steps so far, I have to say. Building in-house, including valves. Now you might be like, okay, why you want to build valves? This is a critical part. While valve is a quote-unquote sorted technology, it's not robust technology. Meaning, can you buy a valve from a manufacturer that's like, no, we know how this works, we have been dealing with LNG or locks, something like that? Yeah, of course you can do. There are a lot of industry that use that. But valves are the primary component in most rocket boom events. Almost all rocket boom events is a valve going kaboom. Be it Boeing booms, be it Blue Origin booms, almost all of them. SLS going back to the launch, basically tower to be refurbished, hydrogen pooping valves, always valves. So they are like, while valve you can buy from outside, you can pay them, it's still hit or miss. So if it's still hit or miss, why don't we try to do it in-house? And again, by the way, SpaceX also does that in-house valves, because again, on paper everybody will clear, oh, take our valves is the best valve, but if it malfunctions, you kaboom a very expensive thing. If it's your own, at least you could do rapid iteration. Now again, if you are a company that can't afford to do rapid iteration, it does not make sense. They can afford to do that. So doing all of these things in-house is a very clever thing, meaning from here to there, everything is in-house. Of course, pipes, they are buying pipes, but other than that, everything is in-house. And building, that's why I'm hopeful for their chances, because of the test site. They built a physical test site where they can go kaboom, boom, boom, boom. I'm just hoping they actually reinforce the infrastructure for a propellant tank going boom, but let's see. So things are looking good. Again, I'm hopeful that they're gonna test it soon, and we're gonna show whether it's gonna be like, engine rich exhaust, or it's actually gonna work. Let's see what happens. But I have to say, Indian space sector is heating up now. And I'm feeling optimistic that by 2030, we should have at least 3 to 5 companies that are like, bro, going to orbit is a easy thing. It's like, then it will be like, how much ton or how high velocity in deep space mission you can do. But this is getting exciting at this point in time. So this was my presentation on basically Astrobase Space project, Everest rocket engine. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst around. That will help me a lot. If you've enjoyed it, click the like button. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.